everyone. Welcome to the second lecture of this online class of ISC Physics. So I just want to remind every one of you that we have already done lecture number 1, that is the first class in physics, in which we have started with one of the first chapter in ray optics, that is spherical mirror. Now in that particular lecture we had just made the introduction. So introduction means like we started with what is spherical mirror, what are the types of spherical mirror, and the terms related to the spherical mirror. Now I just want to proceed today with the importance of the derivation. Especially I focus on derivation, and we follow the sign convention. So for that, one of the two terms I have already defined for you, that is the principal focus that we have already defined, then the focal length. So related to this focal length, and another term also I have defined, that is called radius of curvature. So I am going to derive a relation between the focal length and the radius of curvature. So today we are going to see the radius of curvature and focal length relation based on spherical mirror. So let me continue with this one. So I am telling you, we are in the ray optics with spherical mirror. So to two terms, as I told you just now, focal length and radius of curvature for every spherical mirror. So how many spherical mirror we have? Two spherical mirror. One is called concave mirror, another is convex mirror. Now in order to derive the relation of radius of curvature and focal length, I choose any one of the mirror, because I tell you, whether you take concave mirror or convex mirror, your relation remains same. But the only difference that you can see afterwards, that we usually see in the sign convention, and that also I'll teach you later. So let me take concave mirror. So I'm going to do a relation between focal length. So we usually mark focal length by the symbol F, as we have done in the last class also, and radius of curvature. Radius of curvature, that is symbolized by letter capital R, for any spherical mirror. So I'm telling you again, I'll choose one of the type of spherical mirror, that is called concave mirror. Now in order to derive this relation, now I take a spherical mirror, that is concave mirror of small aperture. That means we learned even in the last class what is aperture of the mirror. It is the diameter or the periphery of the mirror, that is the edges of the mirrors. And this aperture of the mirror determines what type of mirror, whether it is a thick mirror or thin mirror. So we are taking a mirror as that mirror in which we take a small aperture. That means the mirror that we use in our everyday life. So let me take a concave mirror. As you know the shape of concave mirror, this is the shape of concave mirror with silvering surface from the outer surface, and keeping inner surface, the inner surface as a reflecting surface. So I mark again this by letter M1 and M2. So this M1 and M2 is a concave spherical mirror. So this is a reflecting surface, you can see, and this part is a silvering surface. So let me write this as a silvering surface or silvered surface. Silvered, or we also call this as blackened surface. Now let me tell you one important part of this spherical mirrors. You know, mirror is basically a smooth surface. But let me tell you, in smooth or polished surface, we usually follow the laws of reflection. So I have discussed this in the last class also. There are two laws of reflection, in which the first law says that the incident ray, the reflected ray, and the normal and the point of incident all lie in the same plane. Then the next law is the angle of incidence is equals to the angle of reflection. So this law is much applicable in this particular part also. For that, I just want to start with one of the first terms that I've already defined in the last class, that is called pole. That means every spherical mirror has pole. So this is the pole, as you know it. This is the geometric center of a spherical mirror. Now even spherical mirror has a center of curvature. So let me take the center of curvature somewhere out here, and we mark by letter C. Even spherical mirror has a line. There is a line we can draw, a straight line that can join pole and the center of curvature. This line is called principal axis. So let me draw a line, a straight line. This line is called principal axis. Now, in between center curvature and pole, there is a point that lies, and we take that point as F by the symbol, and this point is called principal focus. Now, what is our main target? That means we need to derive the focal length and the radius of curvature. So if you look at the diagram, we can clearly see that PC, the distance, that is the distance from pole to the center curvature, is always taken as the radius of curvature. That means this distance, I can mark in the diagram also, no doubt, is marked by letter R. This distance is called radius of curvature. Even we have a distance that measures from pole to the focus, this distance is marked by small letter f. That means small letter f, PF, I can mark this as PF, is focal length. PC, I can simply call as PC as what? Radius of curvature. Now, to arrive at this particular relation, that means the relation between F and R, let me take the light that has to incident on the spherical mirror. Now, we are taking this mirror as small aperture, a very small aperture. So, I take the light that incident through the spherical mirror in such a way so that the light can reflect. Now, when we come to the reflection of light, it follows the laws of reflection. Now, I am going to apply that laws of reflection in this diagram also. So, let's see. Now, I'll take one of the ray incident on the spherical mirror. So, I am taking this as the incident ray. So, I can mark this as O, and let me take this point as A. So, this OA I consider as the incident ray. So, this is the incident ray. Now, let me tell you one important part. The ray of light that incident through the mirror, if they are incident parallel to the principal axis, is basically considered in two ways. Two rays. One is called paraxial ray, another is called marginal ray. Now, we are taking a small aperture mirror, so we take that ray which are closer to the principal axis, and the ray which is closer to the principal axis are basically called as paraxial ray. But the ray, if goes far away from incident to the mirror, from the far away from the principal axis, that ray is usually called as marginal ray. But we are considering small aperture mirror, so that's why we take that ray, and this ray, incident ray, is also considered as paraxial ray. So OA is the paraxial incident ray as a paraxial ray. Now this is the incident ray. So definitely this point is the point of incidence. I told you in the last class also. So I definitely need to draw a line. This line is called normal. So as you know, normal line always join from the center curvature to the point of incidence. So let me draw a line, a dotted line. This line is called normal. So this line acts as a normal line. Now this is the angle which is made by the incident ray with the normal. And you know what is the statement of angle of incidence? Is the angle made by the incident ray with the normal. So I follow the same statement out here also, and I mark this as I. So I is the angle of incidence. So I can mark I is the angle of incident. Now, in the previous class also, I have taught one of the point that is called principal focus. Now, when we come to principal focus, when the light incident parallel to the principal axis, after reflection, that means light return back, always passes from the point, in case of concave mirror, and this point is called principal focus. So definitely the light reflect and pass from this point. So I am drawing a line. This is a ray, I consider this a ray, and this ray is called a reflected ray. So let me take this as a reflected ray. So this is reflected ray, and this is incident ray. So we follow the laws of reflection. Whatever angle, this is the angle of incidence, sorry, and this is the angle of reflection. So I am marking this by R. So this R is called angle of reflection, and I is called angle of incidence. Now, especially to arrive at this relation, we follow some geometry, a simple geometry that I am going to tell you now. So what geometry we are going to follow? If you look at this particular diagram, OAC, I can mark this as OAC. There is an angle. Angle OAC is usually I. You can clearly see in the diagram also. This is the angle of incidence. Okay, let me write the angle of incidence. Now there is another angle which is made by the reflected ray with the normal, and this angle is called angle of reflection. I can mark this as CAF. Yes, I can write as CAF. CAF. This angle is angle of reflection. I can mark as R. So let me write this as angle of reflection. Now, if you look at these two angles are always equal. That means, we are following the laws of reflection. That means, let me write angle OAC equals to angle CAF. Now, these are equal. Why? Because we are following the laws of reflection. The laws of reflection. Okay. So, let me just give this as 1. So, I am considering this as equation 1. But if you look at the diagram, this is the paraxial ray and incident ray, no doubt. This is the principal axis. But these two rays are even parallel to each other. So you can see the lines are parallel to each other. So if any lines, two lines are parallel, and one of the line you can see as a normal, which can act as a transversal line that we have learned in geometry also. When two lines are parallel and one line act as a transversal line, then the alternate angles are always equal. Now one of the angle is already known as I. Then definitely this angle I means this angle also becomes I. That means these two angles are alternate angles which are equal. So let me write angle OAC is equals to angle ACF. You can see in the diagram also OAC is equals to ACF. Why? Because these two angles are alternate angles. I can write this as alternate angle also. They are alternate angles. Alternate angles which are equal. So I give this as equation number 2. So what you can see from these two equations, the left hand side which is OAC and the left hand side of equation 2 is also OAC. That means these two sides are equal. So that means the right hand side is also equal. So if you compare equation 1 and 2, both sides can be made equal. So you can write by comparing equation 1 and 2, both sides. So I am writing comparing equation 1 and 2 both sides. We can write angle CAF is equals to angle ACF. Now I got angle CAF, that means this angle and angle ACF are equal. That means if you look at the diagram, CAF, it forms a triangle, no doubt. But there are two angles. One is I and there is R. But these two angles, from comparing equation 1 and 2, they are already equal. And you know, when in a triangle, when two angles are equal, then their corresponding sides are also equal. That means if you look at this triangle as ACAF, then these two angles are equal, means then these sides are also equal. So I can make the property of that isosceles triangle. Okay, now you can see angle CAF is equals to ACF. Now in the triangle, if two angles, angle CAF equals to ACF, then I have already shown in the diagram CF equals to AF. So let me write from triangle CAF. So I am writing from triangle CAF, CF equals to AF. This is one of the property of isosceles triangle. Now if CF equals to AF, then we take one of the important consideration. As I told you, the aperture of the mirror is very small. Now when the aperture of the mirror is very small, then the point A, you can see in the diagram, lies very close to P. That means 2 points. That means A and P lies very close to each other, and because of that we are taking that incident ray as a paraxial ray. So if A and C lie very close to each other, then I can write for small aperture of spherical mirror, and we are taking which mirror? Concave mirror, spherical mirror. Point A lies very close to P. So I I've written point A. You can see in the diagram also that is very close to P. So if this is the consideration, then we can see from the diagram also that AF can be nearly equals to PF. That means AF, the distance, you can see in the diagram, is nearly equals to PF. That means two sides of that particular figure are nearly equals to each other. That means we take that are almost equals to each other. So if this is the consideration, then we can easily arrive in the relation of focal length and radius of curvature. So for that also, I again request you to see the figure that we can see in the board also. If you look at the diagram, PC, I have already considered, is what? R. So from figure, if you look at the figure, PC is already equals to R. That is what? Radius of curvature. PF is already equals to small letter f. What is small letter f? Focal length. And what is capital letter R? That is radius of curvature. Now, when these two are the terms that we have already expressed in the diagram, then I can even write PC from the figure as CF plus PF. If you see the diagram again, so I request you to see the diagram also. PC can be split and can be written as CF and PF. That means the sum of CF and PF give you what? PC, which means PC equals to CF plus PF. Now, I have already considered that AF is equals to PF. That means the distance are equal. But AF is also equals to CF. Now you can see in the diagram, CF equals to AF. Now let me just write that CF means AF. Now in the diagram you can see PC equals to CF, but CF is nearly equals to AF plus PF. Now what is AF? That is consider almost approximately equals to and nearly equals to PF. So I write on this is as PF plus, and there is already PF. So I'm getting PC equals to PF plus PF, which means twice the PF, which means I can write 2PF. So PC is equals to 2PF. But we have very much known that this symbol PC and PF is already marked by letter R and F. So let me replace PC by letter R, and 2 into PF I am replaced by F. Now we have got the relation, that is R equals to, that is the radius of curvature, is twice the focal length. Now this is true for any spherical mirror for small aperture. So I have derived this particular relation for spherical mirror, and which spherical mirror we have taken? Concave mirror. But this relation, that is R equals to 2F, is even true for convex mirror, that is one of the type of spherical mirror having small aperture. So R, the radius of curvature of any spherical mirror, is always twice the focal length. So even I can write this relation as F equals to R by 2. Now you can see even focal length of any spherical mirror is always half the radius of curvature. Focal length is always half the radius of curvature. Now let me tell you the important point of this particular relation. Now we have not derived the relation that F equals to R by 2. But I'll tell you the fact that every spherical mirror has made in such a way so that they are provided by the focal length and the radius of curvature. But when you design a particular spherical mirror, the radius of curvature remain fixed. But for a particular radius of curvature, you have a particular focal length. And this focal length and even the radius of curvature will not change even if you immerse a spherical mirror, say in a water. That means by immersing spherical mirror in water, the focal length and the radius of curvature basically remain same. So this is a relation I'm going to apply in a very important derivation that may ask in the ISC also, and that is called mirror formula. So I'll do that afterwards. Now let me just tell you that focal length is just half the radius of curvature. Okay, now we are going to do the next part, and I find this is a very important part in this whole chapter, because when we take the spherical mirror, whether it's a concave mirror or convex mirror, this mirror form either real image or virtual image. Now you know, you have learned even in the lower classes, say class 9 or even at that, Real image is that image which is formed by a mirror by the actual intersection of the rays. That means when the ray of light reflect and they actually meet at a certain point, that image is basically called as real image. And you know what is the characteristics when we talk about the real image? They are inverted image. The size, it can be smaller or bigger, no problem, or it may be equals to. This is a real image. Now we have another image which is, even it can be formed by the spherical mirror, that is called virtual image. The virtual image is that image which is formed by drawing a backward line from the point of incident, because this ray usually not meet at a certain point after the reflection from the spherical mirror. So they usually converge. They usually appears to meet each other at certain point, and in the image which is formed by this spherical mirror is called virtual image. So let me tell you, this is a very important note. Concave mirror and convex mirror, which are the spherical mirror, can form real image and virtual image. Now the question usually arises, which mirror can form real image and which image can form virtual image? Now real image is basically formed by concave mirror. So we can show with I can show with the help of diagram also when we come to the derivation. Now virtual image can be formed by concave mirror, it can be formed by convex mirror. So no confusion out there. Concave mirror form real image as well as virtual image, whereas convex mirror is the only mirror which can form only virtual image. Now let me tell you again, you know it, virtual image nature are basically erect or upright. They are not inverted, and virtual image cannot be cast on the screen. So taking this idea, we come to the very important point, that topic I can say, this is a coordinate geometry sign convention for measuring distances and length. Now distances and length means basically the object distance, the image distance, the focal length, the radius of curvature, and even when we come to the length, we can also count the size also. That means every object which is placed in front of a mirror has a certain size. So when we take the size also, we follow the sign convention. It is called coordinate geometry sign convention. Even when we come to the formation of image, the formation of image, that is either real image or virtual image, that also has a certain size. For that size also we follow what convention? Sign convention. Now why the name has given coordinate geometry? Because we have learned in mathematics, coordinate geometry part also, we usually take two axes. One is x-axis, another is y-axis. Taking these two axes as an x-axis and y-axis, we can simply give the sign whether we measure the distance either as negative or positive, or we measure the size as positive or negative. So we have basically three coordinate geometry sign conventions. I can show with the help of diagram also. Let me first start with number one. So number one coordinate geometry sign convention is the pole of the mirror is taken as origin. That means even if you see the coordinate geometry, so like x-axis and y-axis, we have the origin. So I can show with the help of diagram. Let me take this as x-axis and y-axis. This is y-axis, this is x-axis. Now definitely when we follow the coordinate geometry, we take this as positive sign, this is positive x-axis. We take this as negative x-axis. We take this as negative y-axis. Now we take this point as the origin. So we take this point as a origin in coordinate geometry. But following this particular geometry, I can tell you that the pole of the mirror, that means every mirror has what? Pole. So the pole of the mirror is taken as the origin. So I can take any of the mirror. Let me just take the example of concave mirror. Suppose we have a concave mirror. So you know the shape of the concave mirror. You can take any of the mirror, no doubt. This is concave mirror. So this concave mirror, I am taking this point as the pole. This is the pole. I can mark this as P. And this pole of the mirror is taken as the origin. So we are taking pole of the mirror as the origin. That means whatever distances that we measure, all distances has to measure from the pole. This is very important part that we need to understand. The next, you can see in the board also, the principal axis, the line, you know that is the principal axis means the imaginary line or the straight line that pass from the pole and the center curvature. That line is always taken as x-axis. So let me show you again. principal axis is always taken along which axis? X-axis. That means this is the principal axis. And this line is the what axis? Principal axis. So we are taking this principal axis along which axis? X-axis. Okay, so what means whatever distances we measure, we measure distance along the which axis? X-axis. So this is principal axis. Now let me tell you one important part. This is principal axis, but this line can be extended to the positive side also. The reason is that because this concave mirror can form real image as well as virtual image. Now let me just tell you the important part in this regard with respect to this part regards, that is when a mirror, a spherical mirror like concave mirror or convex mirror or any mirror form virtual image, spherical mirror form virtual image, the virtual image is always formed behind the mirror. That means this is the mirror, this side is behind the mirror. That means this side, that is the positive side of the mirror, is always formed as what? Virtual image. That means virtual image always form this side, the positive side. Whereas real image always form in front of the mirror. That means on the which side? Negative side. Now this is one of the first sign convention that we are following. Now the next point that you can even see is the line passing through the pole and the perpendicular to the principal axis is taken as y-axis. That means you can see this line is the line passing from the pole and perpendicular to the principal axis is taken as which axis? Y-axis. Now this y-axis is also important, very important, because this also helps you to find the size of an object or image that I can show you afterwards. The next sign convention, which is very important, that I can show with the diagram also, is number 2. Distances measured along principal axis to the right of the pole are taken as positive. That means whatever distance you measure taken as along the principal axis and to the right of the pole, that means right of the pole means this side, is always taken as positive. That means this distance, this side distance is taken as what? Positive. And this side distance is taken as what? Negative. So as for the number 2 sign convention, all distances that you measure from pole to the right side along the principal axis are taken as positive. Next, number 3, distances measured perpendicular, let me continue with number 2 only because we have missed out this part. Positive, and those to the left of the pole are taken as negative. That means when we measure the distance to the right side from the pole along the principal axis taken as positive, we can measure the distance on the left side of the pole along the principal axis, and that distance is taken as what? Negative. Now with respect to this sign convention, let me take the case. When mirror is taken, so it form what? Image. But image of what? Object. So as for the case, object should always be placed on the left side. Suppose you have object. So this is your object. You are placing object in front of the mirror. This is the mirror. So when object is placed in front of the mirror, then this object and pole distance is usually marked by letter U, and we mark this U as what distance? Object distance. So object distance. So U is the symbol that we use for object distance. So what is object distance? Is the distance measured from pole to the object. Now if you follow the sign convention, your object distance is taken as what? Negative. So that means you are measuring this side. The distance you are measuring left to the pole, and this distance is taken as negative. So I can tell you, when we come to the sign convention and measuring the distance like object distance, the object distance, whether it is for convex mirror or concave mirror, is taken as negative. This is the example I've taken with the concave mirror. We can do with the help of convex mirrors. Only the shape is different. If I take the same case out here also, I can show you with the help of diagram. So in the same figure, I'm showing you convex mirror also. So I hope you have no confusion out there. This part is called convex mirror. So this is concave mirror, this is convex mirror, with the pole. If you keep the object in front of convex mirror also, what distance is called? Object distance. And that is also taken as what? Negative. Okay, this is for convex mirror also. Now, another distance that we can measure with respect to the pole is called, what distance we call? Image distance. Now, image distance with respect to the diagram, as per the sign convention, can be positive, it can be negative. But let me tell you, when image distance is taken as negative, when the image formed by the mirror, either concave mirror is real. That means when the image formed by the concave mirror is real, then that image is always taken as negative. Now let me just show you with the diagram. Concave mirror, let me tell you, it forms real image, but convex mirror never form real image. So when real image is formed by this concave mirror, this is concave mirror, I am writing the diagram. This is concave mirror and this is convex mirror. Convex mirror form real image on the which side? Left side, because it forms on the in front of the mirror. Why it is formed? Because the ray actually meet at a point, so that you can see when I do the derivation. But real image is always inverted. So I can show you. This is a real image. If this is the object, this is the image. But what image is there? Real image. And why the image is formed here? Because it formed in front of the mirror. So if this is inverted image and the image is real, then this distance I can mark by letter B, small letter b, and this distance is called image distance. So image distance is marked by letter B. Object is marked by letter U. So for concave mirror forming real image, that is formed in front of the mirror, the image distance is always taken as negative. So let me write object distance negative, image distance also negative. This is for what image? For real image. So when real image is formed by the concave mirror, your image distance, as I am writing the sign, is taken as negative. But object distance always negative. Now this is the case of concave mirror forming real image. Now the image which can be formed by concave or convex mirror can be what image? A virtual image. But virtual image always form behind the mirror. That means to the right side of the pole. That means I can just take one of the point. Suppose it formed the image somewhere out there. Suppose, for example, this is the virtual image. Consider this is the virtual image of that object. But let me even make you clear. When convex mirror form virtual image of any object, the size of the virtual image is smaller than the object. So remember it. Convex mirror form virtual image to the right side of the mirror, and its size is smaller than the object. But concave mirror is the only mirror which can form virtual image whose size will be larger. So, okay, let me just add two diagrams of virtual image. So please try to understand this point. One is bigger virtual image, another is smaller virtual image. So what is the main difference? Bigger virtual image is the image formed by the concave mirror, whereas smaller virtual image is the image formed by the convex mirror of that object. That is the main difference. But we are basically focusing out here with sign convention. So we can see the distance, if you measure from pole to the right side, whether it is larger object or smaller virtual image, all the distances, that means image distance with respect to virtual image, is taken as positive. So I am writing for virtual image B, which is nothing but what image? What distance is called? Image distance is taken as positive. So is the sign convention. Image distance taken as positive when the image is what? Virtual. When the image distance taken negative, when the image formed by the mirror is real image. And object distance, whether it's a convex mirror or concave mirror, is taken as negative. Now, this sign convention, I am not only applying for the object distance and image distances, but we have other distances that we can even measure. We have discussed already. Radius of curvature and even the focal length. So let me show you with the help of diagram also what will be the nature, the sign convention that we follow for radius of curvature and focal length for convex mirror and concave mirror. Okay, so let me show you the sign convention, or whether the the radius of curvature and focal length is positive or negative for concave mirror and convex mirror. I can show you for concave mirror. Now just now we did the derivation of focal length and radius of curvature. We are doing for concave mirrors. So this is the shape of concave mirror. So we are taking the shape of concave mirror. This is concave mirror. Now everyone knows this is pole, no doubt. This is center of curvature. Yes, pole, center of curvature. So what distance we call? This is radius of curvature. That means PC, that is pole to center curvature distance, R, radius of curvature. So if you follow the sign convention that we learned just now, this distance is taken as negative because you are measuring the distance left to the pole on the principal axis. The left side of the pole, distance are taken as negative. That means radius of curvature R for concave mirror is taken as negative, which means I can write PC equals to R with what sign? Minus sign. You can see it. PC, the distance is R, but as for the sign convention, minus R. That means concave mirror radius of curvature is negative. So if R is negative, then definitely the focal length, the distance between pole and the focus, is also negative. Now let me tell you one important part. So last relation was F equals to R by 2. See, we have derived all it. F equals to R by 2. That means focal length is just half the radius curvature. This means that principal focus, it lies exactly at the midpoint between C and P. That means F lies between midpoint between P and C. But as for the sign convention, if radius of curvature is negative, then focal length is also what? Negative. So I mark PF equals to minus F. So look at it. R, radius of curvature, PC equals to minus R, negative, because we are measuring this distance. And focal length PF is also minus F, because we are measuring on the left side of the pole. So for concave mirror, both focal length and radius of curvature are taken as negative. Now this sign convention, let me tell you, is very important when we do the numericals, and that numericals we do in the next lecture. Now I can even go to the next, that is for convex mirror. So let me show you out here only for convex mirror. Now you know the shape of convex mirror now. This is the convex mirror with this point act as a pole. Now we see, take center curvature on which side? Right side from the pole. This PC is called what? R, which is still called radius of curvature. So PC equals to R is radius curvature, no doubt. But the sign convention, if you follow, the distance that we are measuring is taken as what? Positive, because we are measuring distance right side from the pole along the principal axis. That means PC is taken as plus R. Similarly, there is a point I can mark as F. So the distance from pole to the focus is marked by small letter F. So PF is nothing but small letter F. And what is small letter F? Focal length, and that is also positive. Now it makes clear for convex and concave mirror. In which mirror we have focal length and radius of curvature negative? Concave mirror. And in which mirror we have focal length and radius curvature positive? Convex mirror. So these are the sign convention that we are going to follow for the next important derivation, I can call, that is important for your ISC examination also, that is mirror formula. So let me continue with mirror formula. Okay, now we are going to derive a very important formula for spherical mirror, and this is the relation, I'll tell you. This is a mathematical relation between three distances. One is called object distance, image distance, and the focal length of a spherical mirror. And this formula is basically known as mirror formula. Now this mirror formula can be derived for both the spherical mirror. One is for convex mirror, another for concave mirror. So I'm not going to do for both the mirrors. I'll do only for one of the mirror, say concave mirror. But your relation will be same for another mirror. Now there are certain assumptions that we need to do when we need to derive the mirror's formula. So one of the important assumption are, number one, every mirror which form image with respect to the object, but the object of a spherical mirror in mirror formula has to be placed on the principal axis of a spherical mirror. That means number one assumption is object must be placed on the principal axis of a spherical mirror. So this is number one assumption. So sometimes you will be asked in the ISC also. Number two assumption is, when we derive the formula, we take spherical mirror of small aperture. So that means the mirror must be of small aperture, having small diameter of a spherical mirror. So this is another assumption. Okay, now we go to the next assumption, that is the third assumption. The distances, whatever distances we measure, like object distance, image distance, or focal length or radius or curvature, all distances have to be measured from the pole. That means all distances are to be measured from the pole. Now, you know why when we take small spherical mirror, then we need to place the object, and that object we also take a small object, and this object can sometimes we also call as point object. So we take object of certain dimension, a small dimension, and this object is a small object that which can form, in which the spherical mirror form image of this object. So with respect to the object, we can see whether the image formed by the spherical mirror will be real image or virtual image. So we usually focus on these three assumptions to arrive at the relation, that is the relation between object distance, image distance, and the focal length. So let me take the case of concave mirror. So I am showing with the help of concave mirror. And concave mirror, what aperture we are taking? Small aperture. So now everyone must know what is the shape of concave mirror. Okay, let me mark this as M1 and M2. This is concave mirror. The mirror is needs the silvering from outer surface and inner surface, keeping as what surface? Reflecting surface. Now, concave mirror, which can form real image as well as virtual image, but I take the case where concave mirror form real image. That means it forms in front of mirror. So, but for that I take the point. One point is called P, that is the pole. Every mirror has a central curvature. Okay, let me mark this central curvature somewhere out there. And we mark another point as F. So this is not exact length or distance. We are taking approximate at the pole, focus, and the central curvature of a concave mirror. Now I take the object, which must be placed on the what axis? Principal axis. So I take the object somewhere in this distance. So, but I take the case where the object is somewhere located out here. So this is the object. So I mark this as O dash, a small object. So this is the object. So I placed on the principal axis of a concave mirror. Now definitely this concave mirror form the image of this object. But let me tell you, and I can show with a diagram, when concave mirror, when object is placed in front of concave mirror, then placed beyond the central curvature. You can see in the diagram, object is placed beyond central curvature. So definitely it forms what image? Real image. And what is the nature of real image? Inverted. And where it is formed? In front of the mirror. So definitely it forms real image in front of the mirror. But where it is formed and what is the nature of the image, that we can show with the help of ray diagram. So before I derive the expression, let me tell you with the help of diagram, there are certain rules, or there are certain rules in which we follow, especially to show the ray incident on the mirror. Now look at it. Object placed in front of mirror, the light can incident from the object in all the direction, but we don't have to take all the directions. So we take only two direction of the incident ray. But for that, I just want to do the rules, or a certain way in which the light reflect in a particular direction when light incident from the object in a spherical mirror. So let me do that part. Okay, let me show you for concave mirror, because we are dealing with concave mirror. Let me take concave mirror. This is a concave mirror of small aperture. You know this is principal axis. I am showing this diagram separately, not with that, because I am trying to show you the rays which can incident on the mirror so that they can reflect in a particular direction. Now suppose if the light incident parallel to the principal axis, as you know very well, the light definitely reflect from the mirror and always pass from the point. And this point is called focus. So this is one of the rules that we are going to apply in the diagram. When the light incident parallel to the principal axis to the concave mirror, the light reflect reflect and passes from the point, and this point is called principal focus. So this is one of the rule. Now I can show you another rule also of the way in which the light can reflect. Okay, you can see the diagram again. Suppose the light passes from the center curvature. Suppose we have a center curvature. If the light happens to pass or incident through the center curvature, suppose, let me show you with the hello diagram. Yes, you can see in the diagram, this is the incident ray. So I'm taking this as incident ray, and this light passing, incident ray passing from the center curvature and strike on the mirror. So definitely light reflect in the same direction. That means when the light incident and pass from the center curvature and reflect, it always reflect in the same direction. The reason is that because this line is a normal line, and when light incident normally, the light always reflect in the same direction. So this is one of the rule that we are going to apply in the derivation of mirror formula. Okay, let me do another one also. Okay, let me take another case of concave mirror in which the light can reflect in a particular direction. Suppose if the light incident exactly at the pole, now look at this point. This point is called pole. This P is marked as pole, and this ray is the incident ray. If the light incident at the pole, definitely the light will reflect, but it will reflect in this direction. Incident ray, reflected ray. So it reflect, incident at the pole means reflect in the same, reflect by make the same angle of reflection. This is angle of reflection and this angle of incidence. But the principal axis, you can see in the diagram, this principal axis act as a normal line. So when the light incident on the concave mirror, the light reflect in the direction, so that the principal axis act as a normal line. So this also we need to apply in one of the topic I'll teach you. The last one also I am going to show you. This is a rule. So I'm taking again the concave mirror with the principal axis, but suppose there is a light passing and incident from the focus. Yes, the light can incident from the focus also. This is the focus. You can see in the diagram, F is the focus. When the light incident and pass from the focus and definitely strike on the mirror, but what happened after reflection? The light become parallel to the what axis? Principal axis. That means it will reflect in the same medium, but the reflected ray become parallel to the what axis? Principal axis. I think these are the 4 different rules which are very much needed, especially when we derive the mirror formula or other relation. So let me continue again with the mirror formula that I was. Okay, let me continue now with the derivation of mirror formula. Now I've already taken OO dash. You can see the diagram. OO dash is the object, small object, placed beyond central curvature. This is one of the case, but not necessary. You have to take at the beyond central curvature. You can take any other point. Now I'll take 2 rays that I've already discussed. 4 rules. Out of 4 rules, I take to apply only 2 rules, so that image of this object will be formed by the concave mirror. So let me take one of the simple rule. The light can incident from the object parallel to the principal axis. Yes, you can see in the diagram. This is the incident ray. Let me tell you again, this incident ray is also taken as paraxial ray. Why? Because we are taking mirror of small aperture. And this incident ray, which are closer to the principal axis, is also known as paraxial ray. So what happened? This point acts as a point of incident. Let me mark this as A. So OA dash is the what ray? Incident ray. So one of the incident ray strike at A, that is A act as a what? Point of incident. What happened as per the rule? It reflect and pass from the focus. So it goes this way. So this ray is the reflected ray. This is the incident ray. So we have followed one of the rule that pass from the focus. But for the formation of image, we need another ray, so that that ray also reflect and meet somewhere at a point. So I take one of the ray also incident from the object, but I'll take the case light passes from the center of curvature. And this is another second rule I have discussed already. And see, one of the ray, there are 2 incident rays, so let me mark by a double arrow. Single arrow means one of the first incident ray, and double arrow I'm showing this is the second incident ray. So what happened when the light incident from the central curvature? Definitely light reflect. It reflect in the same direction, because the line acts as a what? Normal line. So that means the light reflects in the same direction. Let me mark this point as B. So this is the incident ray, this is the reflected ray. So what you can see in the diagram, this is also reflected ray, this is also reflected ray. These reflected ray are meeting each other at a point. We call this point as point of intersection. So definitely if this is a point of intersection, that means the ray actually meet at a point, it forms what image? Real image. Now you know what is the nature of real image? Inverted. Now where the image is formed? For that I can draw a dotted line. So I'm putting arrow facing upward, your arrow in the image facing downward. That means your image is definitely real image. But what type of real image? Inverted real image. Okay, I mark this as, if O is taken, whose image is formed on the principal axis, I can mark this as I. If O dash is taken, whose image is formed on the by the mirror at this arrowhead, means I mark this as I dash. So O dash or O prime, I can call, is the object, and I dash is the what? Image. So let me write O dash is the object, and I dash is the image. Let me write what image is this? Real image, which means inverted image. We can, how can you say that is real image? Because your image is inverted, and inverted images are always real image. This is real image. Now we need to measure the distances. So in order to measure distances, if you look at the diagram, what is this? Object, and this is what? Pole. So distance measured from object to pole is called what distance? Object distance. So if you look at the diagram, OP, okay, let me mark OP as a distance, and this distance is U. What distance called? Object distance. Now let me tell you, when we derive the formula, we need to follow the sign convention. So what is the sign convention? Distance measured from pole to the left side is taken as negative, so U is negative. So object distance is negative. Now image is formed at I, with I dash as the size, from P. So IP, okay, let me mark, distance from image to pole is called what distance? Image distance, and we know it is marked by letter P, image distance. So if you follow the sign convention, your image also formed on the left side from the pole. So what is the sign convention? Negative. So IP is also minus P. But other than this, we have other distances also. Remember it. PC. What is PC? Radius of curvature. PC. Symbol R. We know for curvature, for concave mirror, radius of curvature is always negative. So with sign convention, minus R. Even we have distance from pole to the focus. PF. What is the symbol? Small letter f. What is small letter f? Focal length. And what is focal length? As for sign convention also negative. So we are following sign convention. So all distances in this particular case of concave mirror have negative. So object distance, image distance, radius curvature, and focal length are negative. So we derive relation of U, B, and mostly the F. So in order to arrive the relation, even we follow some geometry out here also. So for that, so you can see in the diagram, I've already taken a point A, lie very close to P for small aperture. So what I do, from point A, I can drop an imaginary line, which is called perpendicular line, on the principal axis. Now this line also acts as normal line and can mark this by letter N. Now the reason I am dropping this line is to follow some geometry, the geometry of similar triangle. You have learned in mathematics also. With that similar triangle property, we can easily arrive at the relation. So look at this figure. We have triangles. They are similar. Now after 4 triangles, with respect to this formation, the 2 triangles which are similar, okay, let me just put with the shaded region. You can see in the diagram, this is a triangle, definitely a right angle triangle. This is also a right angle triangle. These 2 triangles are similar. And you have learned in mathematics class 10, when the 2 triangles are similar, the ratio of any 2 corresponding sides are proportional. So we follow that property. So for this 2 triangles which are similar, follow with the diagram that there are 2 triangles which are similar I can write, since triangles, you can see in the diagram, O dash C and I dash C are similar. That means you can see in the diagram O dash C and I dash C triangle, which are right angle triangle, which are similar. So when two triangles are similar, what is the property? The ratio of the corresponding side. Any two corresponding sides are proportional. But I take two corresponding sides. One is O dash, another is I dash. You can see in the diagram, O dash is the perpendicular side and I dash is also the perpendicular side, the corresponding sides. The ratio, the O dash and I dash is proportional to another side I am taking, that is OC by IC. Yes, you can see OC by IC. That means O dash by I dash equals to OC by IC. So I give this as equation number 1. So I got one of the property. I use one of the property to get one of the relation. But I can show you another triangle, two triangles which are similar. Yes, you can see another two triangle which are similar. That is I dash F and NAF. That means these two triangles are also similar, which means I follow the same property in the next also. That means triangles I dash F and NAF are similar. When two triangles are similar, you can see again the corresponding sides are proportional. So I take two corresponding sides as for the diagram. I take NA or AN. That means AN. Let me take AN, one of the perpendicular side of triangle, by I dash, another perpendicular side of triangle, which is proportional to NF by IF. So I request you to see the both NA or AN, the perpendicular side, and another NF I dash side, ratio is equals to NF and IF. That means their corresponding sides are equal. So I give this as equation 2. So if you look at the diagram, we got two. You got the equation. We got two equations. So if you look at these two equations, I can compare these two equations. But before I compare, you can see AN. We have taken one of the sides, AN. But this AN is also equals to OO dash. That means these sides and these sides are equal. Why? Because these lines are parallel. And when the lines are parallel, then these sides are equal. So I take AN equals to OO dash. That means they are equal as per the diagram. So instead of AN, I can replace by OO dash by I dash equals to NF by IF. So I got equation number 3. Let me write this as equation number 3. OO dash by I dash equals to NF by IF. So this is equation 3. I already got equation 1. So if you compare equation 1 and 3, left hand side is equal. So right hand side is also equal. So comparing equation 1 and 3, both sides you can write OC by IC equals to NF by IF. That means OC by IC equals to NF by IF. Now, the next important part that we need to see out here is we know that the distance is measured from the pole, but out here you can see NF is the distance measured from N to F. That distance is not as per the sign convention, but we need to measure distance from pole. So for small aperture, so I write down for small aperture, N and P lies very close. So if N and P are lie very close, then NF distance is nearly equals to PF. That means this distance, NF, you can see in the diagram also, and PF distance are almost equals to each other. So let me substitute NF by PF. So it is OC by IC equals to PF by IF. So OC by IC equals to PF by IF. So with this equation, we can come to the expression. So OC. Now let me tell you what is OC as per the sign convention. If you follow the sign convention, OC means minus R. Means I'm putting minus R. OC means minus R with sign convention. IC. Now IC is not known, but IC I can write as Pi minus PC. Sorry, PC minus Pi. PC minus Pi. See, if you look at the diagram again, I request you to see the diagram. PC can be written as IC can be written as PC minus Pi. So PC minus Pi equals to PF. We know PF is already F, focal length, with sign negative, minus F. Now IF, again in the diagram, is not known. IF is not any distance, but IF can even written as Pi minus PF. So if you look at the diagram, Pi minus PF can be written as IF. So I'll continue with this one. Pi minus PF is written as IF. Now let me continue with the relation. Okay, now you can, even I can put the values now. This is continuation. Minus R. But what is R? 2F. See, I'm replacing R by 2F for concave mirror. PC. What is PC as per the sign convention? Radius of curvature. Minus R with sign convention. Minus, what is Pi? Distance from pole to the image. That is minus B. But minus what? Plus. Equals to minus F by Pi again is minus B as per the sign convention, minus PF, again minus F, but minus plus. Okay, now the relation is basically with F, so again I replace R by 2F, minus 2F by minus R means 2F plus B equals to minus F by minus F plus F, minus B plus F, sorry. Now let me cross multiply so that I can express the relation. Now let me do the cross multiplication. Minus 2F into minus B plus F equals to minus F with bracket minus F plus 2F plus B. Sorry, there is a distance that we have to measure. Let me do one correction. We have done a mistake out here. Instead of, actually I wrote PC, but actually it's PO. You can see in the diagram. Actually we are measuring the distance IC. So IC means can be written as PO minus, sorry, it is PO minus PC. PO minus what? Sorry. This distance is called PO, the object distance, and we need to know IC. So the distance from PO to the distance PC, that means PC that measure what? IC. So it means the distance I measure, this is PO minus PC. See, please do correct. It is PO minus PC. It's not PI minus PC. It is PO minus PC. So let me do again correction, minus OC. We have already substituted the value. OC, the distance O to C. Okay, now if you see the relation, we have OC by IC equals to NF by IF, but NF means PF. So that OC by IC means PF by IF. But OC in the diagram is not known. But we can write OC as PO minus PC. You can see in the diagram, OC is not known, but OC can be written as PO minus PC. That means this distance is measured as OC. Next, IC. If you look at the diagram IC, the IC is also not known. So IC can be written as PC minus PI. IC can be written as PC minus PI. Yes, IC can be written as PC minus PI equals to PF is known by IF. If you look at the diagram again, it's not known. IF can be written as PI minus PF. Pi minus PF. So it means I replace IF by Pi minus PF. So now let me substitute the value. Now PO, distance. PO means object distance as for sign convention. Negative with minus U. Minus PC. The distance PC means what? Radius of curvature. But minus what? Plus. Then we have PC again, that is radius of curvature, with minus r, minus pi, distance is what? Minus b, so minus minus what? Plus, equals to pf means focal length, minus f with sign convention. Pi means what? Pi means minus b. You can see minus b is pi. Minus pf means minus f, but minus minus what? Plus. Now I can replace again by the relation minus u plus r means 2f, by again r means 2f plus b equals to minus f by minus b plus f. Now this is a simple multiplication, that is cross multiplication we do. Let me cross multiply. It can be written as minus u plus 2f bracket minus b plus f equals to minus f bracket minus 2f plus b. Okay, let me open the bracket. Let me do directly. Minus into minus plus with u into b means ub. Minus into plus is minus. U into f means uf. Plus into minus is minus. 2f into b is 2bf. And plus into plus is plus. 2f into f means 2f square. Out here also minus into minus is plus. F into f, 2f means 2f square. Plus into minus is minus. B into f means bf. Now this 2f square and 2f square cancel out. Now minus 2bf I'll take on the right hand side. So it will be ub minus uf equals to minus 2bf. I'm taking right hand side means 2bf minus, this is already bf. So ub minus uf equals to 2bf minus bf means bf only, plus bf. Okay, so I've done the relation this much. But I take minus uf on the right hand side, so I can write bf plus uf. So ub equals to bf plus uf. Now the relation is basically with ubf, so I can write this relation separately also. So only thing I can do, I divide equation, dividing both sides. Let me write both sides by ubf. So if I divide both sides by ubf, now you can see what happened. We are in the last expression. ub by ubf equals to bf by ubf plus uf by ubf. So you can see ub cancel out, bf cancel out, uf also cancel out. So what is the remaining expression? On the left hand side, 1 by f equals to 1 by u plus 1 by b. So this is the final expression of mirror formula that I derived for concave mirror, but this relation is even true for convex mirror. Thank you.
Good morning everybody. Welcome back to another class where we'll be continuing with fundamentals of partnership. Just a general recap of what we did last week. Last week, we basically emphasized on interest on capital account, interest on current account. We did interest on drawings in detail. We've done the complete concept of interest on drawings. We spoke about profit and loss appropriation, which is the extension of profit and loss account. And we also did rules applicable in the absence of a partnership deed. Now these things are very, very important if we have to continue with the chapter. Now today we will be focusing on partners commission. Now partners commission, basically if just a simple percentage is given, it becomes very easy. Like supposingly it is 5% of net profit. If it is given to you in the question, it becomes very easy. Supposingly your net profit is 2 lakh rupees, 5% of net profit comes out to be 2 lakh into 5 upon 100. This would give you 10,000. So the commission comes out to be 10,000. But problem arises when in the question they say partnership commission is 10% of the amount after charging such commission. So wherever the word after comes into picture, we have to focus on a separate formula, and the formula goes like this: amount into rate into 100 plus rate. So after charging such commission, the formula goes as amount into rate upon 100 plus rate. Supposingly the rate is 10%, so it comes out to be amount into 10 upon 100 plus 10. So this gives you the clear picture, but when the word after is there in the picture. Let's talk about a particular question. I've taken two examples. In the first example, it is just given that 5% of the net profit of the firm, and the net profit being 2 lakh. So this is the first part where 5% of the net profit, it's a simple thing, simple 5% is to be charged. So your net profit is 2 lakh rupees, 5% of net profit comes out to be 2 lakh into 5 upon 100, which is 10,000. Now the second concept, the manager gets a commission of 10% on the net profit after charging A's salary and such commission. Now net profit being rupees 4,60,000 and salary is rupees 20,000. Now let's take up this whole concept in detail, how to go about it and how are we going to represent it through an account. Let's start. First of all, it is given net profit after charging A's salary and such commission. So manager gets a commission. Manager's commission is 10% after charging salary of A and such commission. Now salary of A is very much there in the question. It is given to you, and manager's commission you have to calculate. So let us see. The net profit here is 4,60,000 before giving the salary to A and before giving the manager's commission. Now net profit is 4,60,000 after giving the salary to A. What is the amount left? So salary to A has to be deducted. 20,000 is deducted out of the total net profit. We get 4,40,000. Now the salary to A has been deducted, but manager's commission is not known to us. So manager's commission is 10% of net profit after charging such commission. After charging such commission, it is 10%. So what do we take? The formula is amount into rate upon 100 plus rate. So when we follow this, it comes out to be amount is 4,40,000 into rate is 10% upon 100 plus 10, because it is after charging such commission. So when you calculate, you do the total, it comes out to be 40,000. So manager's commission here comes out to be 40,000. So this is how we calculate the commission given to a manager. So it could be before charging such commission, it could be after charging such commission. If nothing is mentioned in the question, if the word after is not there, it is before charging such commission, and you follow a simple formula, the simple formula being amount into rate upon 100. That's it. But if the word after comes into picture, it goes as amount into rate upon 100 plus rate. So this part is very important. We have to keep this in mind. Okay, so next topic that will be continuing in this topic in this chapter is partner's capital account. Now, last class we studied about partner's capital account, but we'll be doing this in detail because in the coming chapters, partner's capital account is very, very important. So we have basically two methods of doing the capital account. First method says when the capitals are fixed. When the capitals are fixed, you have two accounts which are to be prepared. One is partner's capital account and the other is partner's current account. When the capitals are fluctuating, means the value of the capital can increase or decrease, we have only one account, because in that same account, you write down all details. Now, let us see the format when the capitals are fixed. When the capitals are fixed, what does this mean, fixed? It means that initially when the partner invests some amount, that particular amount as capital investments go in your capital account as by balance brought down. Now, let's take up an example. A and B, they are two partners. A have contributed 1 lakh and B has contributed 2 lakhs. So, this 1 lakh and 2 lakhs, these are the initial capitals invested by the partners. So, this would go into the partner's capital account as by balance brought down, whosoever it could be 2 partners, it could be 3 partners in their account. Now, to continue with this, let's assume that during the year, they have further invested rupees 20,000 each. That means A, to his initial capital investment, he has given 20,000, and B, to his initial capital investment, he has also given 20,000. So this is also a part of capital. So it would go in the capital account as by cash, in bracket, additional capital, that is written. You have to understand, by cash, A has contributed 20,000 and B has contributed 20,000 again. So the total capital of A now is 1,20,000 and the total capital of B is 2,20,000. Now, what do you mean by to cash drawing against capital? This is known as permanent withdrawal from the business. Now, supposingly A had a total of 120, B had a total of 220. Now, out of his capitals, if he withdraws money from the business, it would be written as to cash. So, to cash means the withdrawals done by A and B from the business. So, A has withdrawn 10,000, B has withdrawn 5,000. It would come as to cash 10,000 and 5,000, and ultimately whatever is the balance left, you will balance the account, and that would be the capital of the partner, the closing capital of the partner. Now, what do we mean by current accounts? Current account, supposingly in the question, the balances of current account are given. The balance of current account, if given, it will go in the current account. If it's a credit balance, it is written towards the credit side as by balance brought down. If it is a debit balance, it is written on the debit side as to balance brought down. Now, the partner is supposed to get interest on capital, the partners are supposed to get salary, the partners are supposed to get divisible profit, and the partners also get commission at times if it is mentioned in the question. So, whatever the partners are supposed to get, it comes on the credit side as by interest on capital, by interest on current account, by commission, by partner's salary, and this is the divisible profit that has been distributed amongst the partners. So whatever the partner is supposed to get from the firm comes on the credit side. And on the debit side, the partners, if they withdraw money, like over here, it is written drawings. Now, you will find that drawings are written here in the capital account also, drawings are written here in the current account also. There is a vast difference. Now, when the money is withdrawn out of capital, it goes in your partner's capital account. If the money is withdrawn out of profits, it goes out in the current account. So, two drawings, that is the money which has been withdrawn by the partner and he will be returning back the money to the firm, it goes to the current account. So, two drawings, two interest on drawings, two interest on loan. Now, if a partner has taken a loan from the firm, he is liable to pay some amount as interest to the firm. So, that is also come under current account. And then interest on current account and then share of profit and loss. So, this side is the losses. If supposingly instead of divisible profit, the firm has divisible losses, it will be written on the debit side. Losses come on the debit side, the profits come on the credit side. And whatever is the balance, that will be the balance of the current account. So, in case the capitals are fixed, you have two balances. One is partner's capital balance and the other is partner's current balance. And both these closing balances, the balance CD and two balance CD here in the current account, they are transferred to the balance sheet. So this is when the capitals are fixed. Now, when we talk about capitals which are fluctuating, that means there shouldn't be any bar that the capital has to remain fixed. It can vary. That is how we say the capital is fluctuating. We also say it's floating. So when the capital is fluctuating, you bring down the balance of the capital. You add additional capital here. More or less, I would like to just say that the two accounts that we prepared in the initial topic, we just club in those two accounts and one account is formed. So the balance of capital, the additional capital, interest on capital, commission, salary, and the divisible profits come on the credit side of the partner's capital account. Whereas on the debit side, in case we have a debit balance, it will be written here. Then in case we have a drawing against the capital, it will come here. Drawings against the profits also will come in the same account because we just have one account. Then we have interest on drawings, interest on loan, losses. So these are the divisible losses which are transferred from the P&L appropriation, and ultimately we have the closing capital. Now this closing capital will be transferred to the balance sheet. So this is the basic format. Now, just to understand this whole concept of salary, provision, commission, let's just take up a small question. The question says, Ankit and Bimal are partners sharing profit and losses in the ratio 3:2. Now children, before we solve the question, it is very important for us to understand how do we start with the question. So in order to understand the question better, instead of looking at the whole paragraph, it is better you write it down point wise. So we start like this: Ankit and Bimal, they are partners. They share profit and losses in the ratio 3:2. So if I write it like this, it is very clear that two lines have been expressed in this form. Now their capitals invested were 50,000 and 30,000. So 50,000, 30,000, this is the capital invested by them. Interest on capital is agreed at 6%. Interest on capital is agreed at 6%. Bimal is allowed salary of 2,500 per annum. It is per annum. If per month is given there, we have to multiply 2,500 into 12 if it is per month. But here it has been mentioned as per annum. That means it's an annual salary. Who is given the salary? Bimal. So Bimal's salary is 2,500. What is the interest coming out to be? 6% of 50,000 is 3,000 and 6% of 30,000 is 1,800. So these are the interest, this is the salary. Now whole question, if you express it like this, it becomes very easy for you to carry on with the question. Next they say, during the year ended 31st March, profit prior to the calculation of interest on capital, but after charging Bimal's salary was 12,500. Now profit has been given to you. Profit has been given to you, but that profit is before charging interest on capital, but after charging Bimal's salary. So profit given to you is 12,500. This is before charging Bimal's salary. So Bimal's salary is 2,500. Profit given to you in the question is 12,500. Now profit given to you in the question, please see what is mentioned in the question. Profit prior to calculation of interest on capital, but after charging Bimal's salary. Bimal's salary has already been charged. This is after charging Bimal's salary, the profit came out to be 12,500. So what should have been the profit if the salary was not charged? That is the correct net profit. So if you add Bimal's salary to it, it comes out to 2,500. So this total comes out to 15,000. So the net profit, the correct net profit over here is 15,000. This part has to be remembered. Now, why is it important? Because the P&L appropriation shows the salary to be given to the partner comes on the debit side. But in the profit, if we actually deduct the salary and write down and we give salary again, the salary will be given twice. We cannot do that. So first of all, we have to add back the salary that has already been given to the partner. So after adding back the salary, the net profit comes out to 15,000. So this is the correct net profit. Now, provision of 5% of the net profit is to be made in respect of manager's commission. So which is the correct net profit? The correct net profit is 15,000. Whatever commission is to be given, whatever interest is to be given, it has to be given on the correct net profit. So 12,500 was not the correct net profit. The correct net profit is 15,000. So 5% of 15,000 comes out to be 750. So this is the manager's commission. Manager will be given 750. Now giving commission to the manager is not a part of appropriation. Giving manager's commission comes under the profit and loss account. So in the profit and loss account, which we have already prepared, so we do not know. So how to go about it? Just see over here, the solution has been done. The net profit we brought down from the P&L account was 12,500. We added back Bimal's salary, which was 2,500. So the correct net profit was 15,000. But 5% had to be given as manager's commission. It is a charge against profit. So we have to deduct the manager's commission. So when we deduct 750 out of 15,000, we get a total of 14,250. So this will come in your amount column. So you have to show the working like it has been shown here. And then the interest on capital for A was 3,000. For B was 1,800. We do the total and it comes out to 4,800. Salary to B. Now, because we added back the salary to the net profit, we can give salary to B again, which is 2,500. And whatever is left towards the end, that is your divisible profit, it will be distributed amongst A and B in the profit sharing ratio of 3:2. So 6,950 into 3 by 5 will give you 4,170, and 6,950 into 2 by 5 will give you 2,780. So this is how we go about with the question. If you write the question in this format initially, it becomes very easy for you to comprehend. Now this is the working note, how you are going to show, because working notes also carry marks in the exam. It is always advisable not to do it orally, just to show how the answer was derived. So correct net profit was 12,500 plus 2,500, which is 15,000. Manager's commission was 5%. So 5% of 15,000 came out to be 750. Then interest on capital. Interest on capital was 6%. So 6% of 50,000 is 3,000. And 6% of 30,000 is 1,800. And then the divisible profit was distributed in the ratio 3:2. Now, how to go about with the partner's capital? Now, the question was silent. Which method was followed? Whether it was fixed or it was fluctuating. So, when nothing is mentioned in the question, we follow the method of fluctuating. When we prepare only one account, and that is the partner's capital account. So, in the partner's capital account, we brought down the capital balances. The capital balances were 50,000 and 30,000. So, we brought forward the balances as by balance brought forward 50,000 and 30,000. The next content there is by interest on capital. The partner is supposed to get interest on capital from the firm. So it comes on the credit side. By interest on capital, 3,000 and 1,800. by salary. B is supposed to get a salary of 2,500. So we've not given anything to A. The salary amount goes to B's column. And then ultimately the divisible profit that was calculated in the P&L appropriation account, 4170 for A and 2780 for B. This side we did not have any drawings in the question. We did not have any interest on drawings in the question. So we've not written anything on the debit side of the partner's capital. It's just the balance which came up to balance CD. We did the total and that was the balance. Now this balance goes to the balance sheet of the firm. The closing balance sheet, when we prepare, these figures will be going to the balance sheet of the firm. Now, I hope this was clear to you. We spoke about partner's capital account. We spoke about manager's commission. The last topic for today that we'll be taking up is guarantee of profit. Now, 4 marks question on guarantee of profit, 4 marks question on past adjustments. These days, they are very frequent. So these questions have to be emphasized on. And these are very simple topics. Guarantee of profit. Now, there are 3 ways in which one guarantees. Guarantee basically means assurance. So, one partner guaranteeing another partner. What is the basic meaning? The meaning says, one partner says that, okay, I will be giving you the deficient amount if you don't get whatever is desired. Like, for example, A has guaranteed B. So, in case B does not get whatever is asked for, A will pay out of his own pocket. For example, supposingly A had guaranteed B a sum of 5,000 annually. That in no case B will get less than 5,000. This was an assurance. What happened? Supposingly after all calculations towards the end, B is only getting 4,500. So how much is the deficiency? The deficiency comes out to be 500 rupees. Now, B will not compromise on this 500 because B had been assured, he had been guaranteed by A complete amount of 5,000. But here he is only getting 4,500. So what is B supposed to do? B is going to ask A, and A from his pocket, he will pay 500 to B. What would be the journal entry in this case? The journal entry would be A's capital account debit to B's capital account. A will be getting the money from B. How much money will A give from his pocket to B? He'll give a minimum of 500 to make his guaranteed amount complete from 4,500 to 5,000. This was one partner guaranteeing another partner. Now, supposingly in the question, there were 3 partners, A, B, and C. And the guarantee was between A and B. C will not give anything from his pocket. C will stay quiet because he did not guarantee B. It was A who had guaranteed. So, if A guarantees, A will give from his pocket to B, whatever is the deficient amount. Supposingly, A was guaranteed 5,000 and A, after all calculations, he is getting 6,000. So, there is no deficiency. So, in that case, B will be given 6,000 and A will not have to do anything because actually the minimum guarantee was 5,000, but he is actually getting 6,000. So, A will not do anything, B will get 6,000. If there is a deficiency, A bears from his pocket and he gives it to B, and the journal goes like this. The second concept says the firm guarantees a partner. Now, if a firm is guaranteeing a partner, what does a firm comprise of? First of all, let us understand that. Let's assume there are 3 partners and the firm has guaranteed C. Firm is guaranteeing C. Now, what do you mean by a firm? A firm comprises of all the partners here. Who is being guaranteed? C is being guaranteed. That means the remaining 2 partners, they represent the firm in this case, and both the partners will bear the deficiency. Now, for example, C had been guaranteed a minimum of 10,000. C was guaranteed a minimum profit of 10,000, and after all calculations, the profit that C is now getting comes out to 8,000. So what is the deficiency? The deficiency is 2,000. This is the deficiency. Now, who is supposed to bear the deficiency? Both the partners will bear the deficiency in their profit sharing ratio if nothing is mentioned in the question. So, if supposingly the profit sharing ratio was 1, the deficiency will be borne by A and B in the ratio 3:2. So, 3 by 5 into 2,000 and 2 by 5 into 2,000. So this comes out to be 1,200 and this is 800. That means A will bear a deficiency of 1,200 and B will bear a deficiency of 800. And what will be the journal in this case? The journal would be A's capital debit, B's capital debit to C's capital. Both of them are giving, A is giving 1,200, B is giving 800, and C gets whatever was assured. C was assured a sum of 10,000, he got 8,000 from the firm, and the remaining 2,000 deficiency he will be getting from A and B in their profit sharing ratio. This is how it goes. The third guarantee is a little different because in this case, it is not one partner who is guaranteeing another partner or the firm who is guaranteeing the partner. Here it is vice versa. It goes like a partner guaranteeing a firm. Now, A plus B plus C. This comprises of a firm. If the question says that C has guaranteed that because of C, the profits shall go up to 80,000. And in the question it says profits for the year are 75,000. Now what was the guarantee? 80,000. But what is the profit? 75,000. That means C did not meet his guarantee. So whatever is the deficiency here is 5,000. So 5,000 rupees worth of deficiency C is going to pay from his capital account to the other partners. So in this case, when we prepare the P&L appropriation account, the net profit, whatever was there, is 75,000. But what was the assurance? The assurance was for 80,000. So we will add here C's capital account. By C's capital account, it will come out to be 5,000. C will pay 5,000 from his capital account to make the complete profit go up to 80,000. And the remaining question will follow as it is. The only difference being, over here on the credit side of the P&L appropriation account, we have to write down by C's capital account 5,000, because here C is paying the extra 5,000 which was the deficiency, because C had assured 80,000 and the profit came up to only 75,000. So the difference of 5,000 he will pay from his own pocket. So these are the three methods of guarantee of profit. Questions are asked on the basis of cumulative question also. You might be given this kind of a thing where the concept of guarantee is asked in P&L appropriation account. If not, a separate question on guarantee can also be asked, which would comprise of 4 marks. Now, this is a small question that we've taken up. Just let us see. Vicky, Vijay and Vinu are partners, sharing profits in the ratio 5:4:1. Vinu is given a guarantee that the minimum share of profit in any year would not be less than 5,000. So Vicky and Vijay, both of them have guaranteed Vinu that Vinu, your profit will not be less than 5,000. Now, deficiency, if any, would be borne by Vicky and Vijay equally. Now, there is a slight twist. In the previous question, I explained it was 3:2:1. So, the deficiency was borne by them in the ratio 3:2. But here in the question, they have already explained that the deficiency, if any, would be borne equally. So, the deficiency, if arises, Vicky and Vijay, they are going to give equally to the partner. Now, the profits for the year ended 31st March was 40,000, and nothing else has been given to you in the question. That means they are basically trying to emphasize on the guarantee concept. So, the profit is 40,000. Let us see how the question goes. Vicky, Vijay, Vinu, they share in the ratio 5:4:1. Vinu's share of profit, a minimum of 5,000 has to be given to Vinu. But when we calculate the share of profits, in this case, Vicky is supposed to get 5/10, Vijay is supposed to get 4/10, and Vinu is supposed to get 1/10. The profits have been bifurcated as 5:4:1. And when we calculate Vinu's share, that is 1/10 of 40,000, it comes out to be 4,000. What was the guarantee? The guarantee was 5,000, but Vinu is getting 4,000. That means there is a deficiency of 1,000. So who is going to bear the deficiency? The deficiency will be borne by Vicky and Vijay. But in what ratio? It has been mentioned in the question that the deficiency will be borne equally. So half-half. That means 1/2 and 1/2. Vicky will be giving half of 1,000 to Vinu, and Vijay would be giving half of 1,000 to Vinu again. And what will be the journal? The journal comes out as Vicky's capital account debited, Vijay's capital account debited, and who's the recipient over here? Vinu is the recipient because Vinu was guaranteed a minimum profit of 5,000. But out of the firm, Vinu only got 4,000. So the difference of 1,000 will be given to Vinu by Vicky and Vijay equally. So this was all about guarantee. Now there are numerous questions given in the book. So please try solving that. In the fundamental chapter, we are left out with just one topic, and that is past adjustments. We'll cover that in the next class, and in the next class, we'll be doing the goodwill concept also. So please try and solve questions. Please see the details, read the chapter, look into the illustrations. It will be very easy for you to do it. Thank you.
Hello children, and welcome back to another session of ISC Sociology online video lectures. Let me start my video lecture by quoting some few lines from the movie Jungle Book. I hope you will find these lines inspirational because today's lecture will be mainly based on the concept of relationship. So let me read out the line. This says, "Now this is the law of the jungle, as old and as true as the sky. And the wolf that shall keep it may prosper, but the wolf that shall break it must die. For the strength of the pack is the wolf, and the strength of the wolf is the pack." Let me just repeat the last lines. For the strength of the pack is the wolf, and the strength of the wolf is the pack. So like I told you, the whole concept of relationship is given here in these few lines, where it has been explained or been described that the beauty of relationship is relationships will survive as long as individuals do, and individuals will survive as long as relationships are strong. And this will be the main lesson content for today's video lecture. Like I had promised last time, today I'm going to start off specially with the Kinship chapter. And before I deal with the Kinship chapter, let me quickly read out to you the syllabus as has been framed by the Council. If you just look at the kinship structure, it says you just need to learn the meaning of kinship, the types of kinship, consanguineal as well as affinal. You have to discuss the degree of kinship here, which are 3 degrees, the primary, the secondary, and the tertiary. It also asks us to learn about the descent. There are 2 types of descent that you will have to study. One is matrilineal descent, the other one is patrilineal descent. Then in case of residence, you have to study matrilocal, patrilocal, and avunculocal. It says here, discuss kinship usages. And there are 6 usages given here: avoidance, joking relationship, technonymy, avunculate, amitid, covade, and also discuss the descriptive and classificatory kinship terms. So this is the skeleton, this is the framework that has been given by the Council, and we will also go accordingly with it. So let's kickstart today's session with the study of kinship. Here I have just made an outline. When we study the chapter kinship, we will definitely learn about the meaning, the types, the degrees, the range, the usages, and the terms, which are again, as I had explained earlier, are there in your syllabus. Now, coming to kinship. The definition for kinship normally comes for 2 marks. Define kinship. And let me remind you, in 2019, in the short answer section, in the compulsory section, there was a question, define kinship, for 2 marks. Let me just remind you, this lecture is not only beneficial for the candidates of 2021 examination, but those of you who are due to give your examinations in almost next month, you can also benefit from this, because this will be more of a revision work for you all. It says here, kinship is referred to as universally acknowledged basic bonds that binds all individuals together. And whenever I have explained kinship, I've always told my students, just imagine yourself as a spider and you are in the middle of the web that you have just woven. A spider's web is very intricate, it is very fascinating, and in that pattern, just imagine yourself as that little spider. The web actually represents the kind of social relationships that we have woven. By social relationships, I mean you have a father, you have a mother, you have an uncle, you have an aunt who's related to you, you have your grandparents, you must be having a sister-in-law, you might be having an aunt-in-law, etc. So in the middle of those relationships, we have that spider who has to maintain or balance these relationships as well. But can you just imagine how this entire weaving of this entire web must have started? It says here, it explains the genealogical relationship which could be based on actual or supposed ties of blood. Meaning, the start or the origin of kinship will begin from the relationship between a man and a woman. Once a man and woman marries, and they have children, they reproduce, then what happened is the children will also grow up, they will also marry somebody else, they will also have children. In this way, we will have multiplication of family members, and along with the multiplication of family members, we will also have the multiplication of social relationships. And if we have to go backwards, if somebody will ask you, how are you related to that person? Normally we say, he is my father, she is my aunt. Oh, he is my aunt's husband. Oh, this person is my aunt's son. So in this way, we explain, we go back to our origin and we explain the relationship. So when we are talking about kinship, first and foremost, what we have to understand is the genealogical relationship. How are you related to that person? So that person is my father's father, that person is my aunt's sister, that person is my mother's brother, etc., which could be based on actual meaning real, or supposed ties of blood. While dealing with kinship, what we normally do is, we do not take into consideration only our blood relatives, but we also take into consideration the adoption cases also. We also take into consideration those children who have been socially recognized by the society as somebody's child, as somebody's family member. Therefore, in kinship, we have two things. We have both actual as well as supposed ties of blood relationship that we will be studying about. So I guess that I have already defined kinship. Let me remind you once again, this comes for 2 marks. Next, meaning of kinship. Kinship starts from, I have repeated this, from the relationship between a man and a woman. The basic foundation of each kinship relation is reproduction. And we normally do not go into the theory of who were the first 2 individuals on earth, or how did this human society start. We do not go into all those details. We straight away, we study that once upon a time there was a man, there was a woman, they married, and then they had children, and this is the foundation of the kinship relationship. Next is, kinship is found among all levels of culture. By culture, I mean both primitive as well as modern. You might go into any tribal culture, or you can go into primitive culture. You can go there for your case studies or for your field trips, etc. And you will definitely come across their kinship structure. And if you compare it into modern societies, there also you will come across the same kind of relation. So the kinship relation exists among all levels of culture. Many a times, I personally have also faced a problem explaining to children what is kinship. And this is what I have always said. The relationship between friends is called friendship. Friendship meaning the relation that you have with your friends. Similarly, kinship meaning the relation that you have with your kins, with your family members. Sometimes understanding kins is a problem. So in Hindi, in Nepali also, I would like to use this particular word. We call it rishte or nate. So when I call it rishte or nate, I think it will become easier for you to understand this entire concept of kinship. Kinship can also have a diagrammatic representation. So let me draw your attention towards this diagram. Here, let me explain to you. A male member is always represented in the form of a triangle, and a female will be represented in the form of a circle. So let's look at the first family. Anil, a male member, got married to. Now this equal to sign that you can see over here, this represents marriage or a marital relationship. Got married to Maya, and they had 2 children. One is a daughter, that is Nita, and the other one is a son, that is Sulabh. So here we have a diagrammatic representation of a kin relation. Now, if somebody will ask, what is the relationship between Anil and Maya? It is very easy to say they are husband and wife. Or if somebody will ask, how is Nita related to Anil and Maya? She is the daughter. Sulabh is the son. Anil becomes a husband. Actually here, Maya is a wife. But for these two, daughter and son, Anil is also a father. Maya becomes a mother, or if you have to put it together, these two are the parents and these two are the children. So look at the set of social relationship. Anil is performing the social role of a husband, a father. She is the wife. She is somebody's mother. These two are children. And between Neeta and Sulabh, they also have another relationship, that of siblings, that of brother and sister. So this web that I was talking about, the spider, let me remind you of that spider in the middle and the web that it had just woven. This entire web, it represents that. So if you remember the spider, the web that it had just woven, this is the web that I'm talking about. Husband, wife, parents, siblings, brother, sister, children. This entire web of relationship is known as kinship. So I feel that through this diagram, now many of you must have understood what is the meaning of kinship. And it all starts, like I said, the basic foundation of each kinship relation is reproduction, which starts from the relationship between a man and a woman. And it keeps on spreading, because if Neeta gets married, or Sulabh gets married, they have children, the family will keep multiplying, and this web will also start increasing in size. Now let us come to types of kinship. We have already seen the definition of kinship. You saw the meaning of kinship. I just shown you here the diagram of kinship. But now let us look at the types of kinship. There are two types of kinship. One is consanguineal kinship and one is affinal kinship. Now in many a question is just written, discuss the types of kinship. And many children, they get confused. Sometimes they do not know whether there are two types or three types, etc. Maybe this visual diagram here will help you in understanding or in memorizing that we just have two types of kinship. One is consanguineal and the other one is affinal. Let us look at the meaning of consanguineal. The relationship which is born out of blood or supposed ties of blood can be defined as consanguineal kinship. And I've given you the example of consanguineal kinship here. Mother, father, siblings, grandparents all come under consanguineal kinship. The operative words here are blood relation. You have to be tied, all right, with this blood relation. And the other one is it can also be supposed, meaning you can also consider adopted children as consanguineal kins. So this consanguineal kinship, this entire concept of consanguineal kinship actually relates to the relatives of family members who are related to you by blood. So all your father's family, all the members of your mother's family, they will come under the consanguineous kin group. And the examples of consanguineous kins are here: mother, father, siblings, grandparents. Again, let me bring you back to this diagram here. All right? The relationship between parents and children. I'm not going to Anil and Maya. The relationship between parents, this vertical line that I have drawn here, parents and children is known as consanguineal kinship. The relationship between siblings, again related by blood. Neeta and Sulabh are related by blood. These two children are related by blood with their parents. This entire relationship can be referred to as the consanguineal kinship. And now let us discuss, now that we have already seen the definition, let us discuss the features of consanguineal kinship. These are the features and characteristics. The relationship deals with blood relatives. I've already explained to you. The first thing that you will look out for is, are you related by blood or not? Meaning, are you a family member or not? The second one is, relationship between the relatives are very close and informal. Think about your own cousins. Think about your own family members. The relationship that you have becomes very close. What do I mean by close? You're very intimate. You do not need to pretend. You don't have to create a drama when your family members are visiting you. And especially in the Indian context, we feel very free and we are very casual when it comes to our family members. And also, the relationship is informal. Now just imagine a situation. Your uncle has just walked into your house and you want to offer him tea. Now, it is not that you're going to clean up the house and you're going to give him a very high tea party or like that, or you're going to have a different set of behavior in front of your uncle. It's not like that. You would serve him tea as you would serve it to the members of your family. Why do you have this behavior with your uncle? It is because you are related to him by blood, because you have a very close relationship with him. You do not need to pretend, and because of that, your whole relationship becomes very, very informal. Next, disputes and arguments do occur amongst them. This is the best part of relationship. This morning, I was just reading somewhere that relationship is just like a house. Just listen to this. It's very interesting. Relationship is just like a house. Sometimes you might have a broken bulb. But then, just because a bulb is broken, you do not buy a new house. You will fix the bulb. So this is the interesting part about consanguinal relationship also. It's not that you are going to have happy days all the time. Just remember your own families. You might have one uncle not talking to the other. You might have jealousy amongst the cousins. You might have one aunt who is always tattling or who is always complaining. But the beauty of this consanguinal relationship is, with all these hitches, you carry on, you move on in life, and this is the beauty of relationship. So here it says here that disputes and arguments are very common, even in your own house. Maybe the son does not agree with the father, or the daughter has some problem with the brother. But in that case, relationship does not end. Dispute, in spite of the disputes and arguments and fights and quarrels, right, the relationship will move on. Why do we have to move on? It says here, they are expected to help each other financially and emotionally. And the best representation of this is often shown through the Hindi or Bollywood movies. You always see that in a joint family kind of structure which they have, you have maybe a very scheming daughter-in-law or dispute between mother-in-law and daughter-in-law. And then you will also see sometimes there are happy times when everybody is singing and dancing, or there might be times when they all are crying together, or there might be times when they are facing difficulty in their lives financially, emotionally. Right now, we all are facing this crisis situation. We are in the middle of a pandemic right now, and you all know how it is. But your parents have emotionally supported you. Parents are financially supporting you. So, in spite of quarrels, in spite of fights, life still goes on. Relationships have to be maintained. So what happens is, the consanguinal relatives are expected to help each other financially as well as emotionally. Last but not the least, the presence of kins. Now this is very, very important, because I've often seen over the years, the kinship structure has also changed. The growth of nuclear families has brought drastic changes in this organization of kinship, because no longer you find families who are very close and informal, like I have explained earlier. But then the presence of kins are required. Because you are a family, you have to be there, you have to be present during certain social occasions, like it's written here, birth ceremony. There's a child which is born, a new member has come in the family. Whether you like that sister or not, whether you like to see the face of that aunt or not, we all make it a point, yes, we have to go and attend that ceremony. Marriages. Two uncles might not be talking to each other. Yet, in front of the guests, in front of the outsiders, what kind of picture do we portray? Yes, that we are united, that we all are one. And then the marriage is also celebrated in the same manner. Next is the funeral. In case of a loss of any family member, if anybody passes away, of course it is a very sad occasion. But see, we have a happy occasion here. These two are very happy occasions here. We celebrated. But here, this is a very sad occasion. So if we can support each other during happy occasions, then definitely we have to support each other during the sad occasions as well. So during funeral ceremonies, etc., you must have seen in your own localities, in your own groups, etc., people come from far and wide just to attend the funeral ceremony. And the reason why you're doing this is because you're trying to maintain your social relationship. You are trying to perform your duty as a family member. So these are the features or characteristics of the consanguineal kinship group. Next we come to affinal kinship. Let's go by the definition again. In affinal kinship, the relationship is born out of marital ties. Marital ties meaning marriage. And we cannot have marriage within the family itself. We have to get married to somebody who is not related to us. So here, if you marry someone and then that person becomes your husband or your wife, then we refer to this relationship as affinal kinship. Now, while explaining affinal kinship, even in most of the diagrams, you just have the representation of a man and a woman. Like, I would like to again ask you to look at this diagram here. We started first with Anil and with Maya. Anil got married to Maya, so they turned into a husband and a wife. This equal to sign here, where I have written, shows the relationship of marriage or marital ties. This will be referred, it's actually this way. This is actually known as affinal kinship. So in consanguineal kinship, we were talking about blood relation. In affinal kinship, we are talking about the relation which is born out of marriage, which is born out of marital ties. And here you just see a triangle and a circle. Many times we get confused, and I would like to again tell you all students that please do not imagine, most of us have gone for the weddings, all right? And when we go for the wedding, we see the bride and the bridegroom. And we often feel that, yes, these two are getting married. Sometimes a wedding card invitation comes to your house. Okay, so-and-so is getting married to so-and-so. That's the only thing that we look for. What we need to understand is affinal kinship is not only about the husband and wife. It is not only about the man and the woman. It is about the man, the woman, and the groups in which they are getting married to. For example, here, Anil has his own family. Here, Maya also, she has her own family. But we mistake and then we feel that, yes, only these two are getting married, but we sometimes neglect the family. In affinal kinship, we cannot neglect the family, where two individuals are getting married to each other. These two families are also getting tied to each other through this marriage. So the family also becomes equally important. That is why, while marrying also, because we'll be dealing with the marriage chapter later on, there is a separate chapter on marriage. Over there also, I normally explain to my children that it is not only about a man and a woman, it is also about the groups in which you are going to get married to. So it's written here, the relatives are known as affinal kins, husband, wife, all right, affinal kins, mother-in-law, daughter-in-law, father-in-law, sister-in-law, grand-aunt-in-law, grandfather-in-law. all the in-law groups will be addressed as affinal kins. And I've given you the example here for your better understanding. Mother-in-law, sister-in-law, husband, wife, they will all come under affinal kins. Now for a moment, just think about these two terms, mother and mother-in-law. And just try to imagine your behavior with a mother and your behavior with mother-in-law. With your mother, like if you ask for a certain dish to be cooked, and if the mother doesn't serve you with that, yes, you can afford to do anything. Get inside the room, slam the door. I'm not going to eat till that dish is served on the table. You can do anything to your mother. Can you do the same thing to your mother-in-law? You can fight with your mother. You can argue with your mother. You can love your mother. You can share anything with your mother. Can you do the same thing with your mother-in-law? So there are two individuals, but with two individuals, you have two sets of behavior. Just recap the behavior with consanguinal kins. Close, informal, very casual. But with affinal kins, you cannot afford to do that. Why? Because they are not related to you by blood. They are related to you through marital ties. Now let's look at the features of affinal kinship. This relationship originates out of marital ties. Relationship among kins are formal and distant. So this differentiation that I gave you a while back between a mother and mother-in-law, the kind of picture that I just created is to show you how we behave with your mother. A mother is our mother. We can do anything with her and she will forgive us as many times as we wrong her also. But with the mother-in-law, it cannot be that, because the relationship that we are expected to maintain, the society has licensed this relationship, is it has to be very formal and it has to be very distant. Distant and formal meaning respect has to be there. In case of dispute with consanguinal kins, the affinal kins become more important. This usually happens when you have an only child. Just imagine a situation where you only have one daughter in the house, all right? And then maybe the daughter comes from a very rich and well-to-do family. The father might be pressurizing the daughter, don't go and stay with the husband, bring the husband over, all right? In such kind of cases, what happens is that if the son-in-law is pressurized, or maybe the son also has his own family, the mother also wants the son to stay with her only. In that case, if there is a dispute with the consanguinal kin, let's say the son has fought with the father or has had a big quarrel with his own brother, doesn't want to stay in the house at all. And remember, his wife is the only child. In that case, the affinal kins for him will become more important. So he might go and live in with the wife. He might feel that the father-in-law is more important. So if one kin group is not so good to you, if you're married, the second group will also come useful someday. Next, affinal kins can also help emotionally and financially. Look here. Look at this diagram again between Anil and Maya. Since they are husband and wife, they will help each other emotionally as well as financially. Today, almost everybody works. All the husbands and wives, they are working. But there was a time when most of the women did not work. So they were depending on the husband. But the husband, in some cases, never made the wife feel that she's not earning. The husband felt that my wife is my financial responsibility as well. From now on, I will have to give that emotional, psychological, material, financial support to my wife. So therefore, when we are talking about the relationship with affinal kins, emotionally and financially. Next one, sometimes the relationships between kins can become difficult. This is nothing new. We have fights, we have quarrels. Even among blood relatives, we have that. Father and son not talking to each other. Brother and sister not talking to each other for a long time, considering each other as one of the worst enemies that they can deal with. So here, between the kins can become difficult because of interference of another member. And usually this happens in marital relationship. If the mother-in-law is very interfering, or there might be a sister-in-law who's very interfering, or somebody in the house who's trying to create trouble, then relationships can turn into a mess if we have, the watchword here is interference. So if you want to make your relationship better, this was also given in Panchsheel when the non-aligned movement was being organized. It was Jawaharlal Nehru who gave this mantra of mutual non-interference. If you want your relationship to sustain, if you want it to become better, the one formula that you have to follow is non-interference. So here, if you have interference, then it might also lead to a difficult relationship. So with this, we have discussed the two types of kinship. Consanguinal kinship, let me recap once again. It is a relationship which is born out of blood and also supposed ties of blood. We are considering all our family members in consanguinal kinship. We have discussed that we have to be together with each other during certain occasions, social occasions like birth and marriage and funeral. Relationship is very casual and very informal. And we also discussed that in spite of the disputes and the quarrels inside the consanguineous kin members, yet during difficult times, you are expected to be with each other. Whereas in the filial kins born out of marriage, husband, wife, mother-in-law, father-in-law will all come under this filial kin group. They also support us emotionally and financially, but sometimes relationship can turn sour if you have an interference from any other member. All right, so with this, let me come to ISC questions before I forget. The common ISC questions that you get is definition, for 2 marks, define affinal-kins, define consanguinal-kins, differentiate between affinal-kins and consanguinal-kins, again for 2 marks, whereas in the long answer section, you might have, sometimes they will give you the terms itself. Discuss affinal and consanguinal, it's very, very easy. But sometimes, just to confuse you, they might just ask you to discuss 2 types of kinship, where they have not given you what are the 2 types. And the diagram that I gave earlier, remember, of kinship and its 2 types, maybe visual representation will help you to discuss the 2 types of kinship. Now let us come to the second topic, that is degrees of kinship. Degrees of kinship, you can see here, we have 3 degrees, starting from primary, secondary, and I will come to tertiary. But first and foremost, we need to understand what is the degree of kinship. Degree of kinship refers to closeness, distance among individuals who belong to a kin group. Usually, ISC gave questions like, what are the 3 degrees? Degrees of kinship always came in the long answer section where you were asked to discuss the degrees of kinship along with examples. But in 2016 onwards, when the question paper pattern also changed, then one year they asked what is the degree of kinship. Instead of asking, give the types of degrees, they asked, what is degree of kinship? And many children found it difficult also because they had not understood the meaning of the degree of kinship. So before I explain to you the degree of kinship, I would like to take some time and explain to you the meaning of the degree of kinship. It refers to the closeness or even the distance among individuals who belong to a kin group. Look at the diagram here again. Let us look at the relationship between Neeta and Anil and Maya. Right? So if anybody, or you think about your own family, you need not follow the diagram. This is just an example. If you want to, you can just close your eyes and think about your own family. What kind of relationship do you have with your father and your mother? For most of us, eyes closed, we will say we have a very close relationship, right? Many a times, your father might have scolded you, your mother might have punished you, but then we don't think about those things at all. At the end of the day, we only have those happy thoughts. We only have those happy memories that we have spent with either our father or our mother. So here we have, if you look at the family chart over here, the relationship between these individuals will become very, very close. Now, if I talk about, let's say, Sulabh, if somebody will ask Sulabh, what kind of relationship do you have with your grandfather's, let's say, cousin brother? Then he might say, okay, with my grandfather, with my father I am close. With my grandfather, okay, not very close. Now, with my grandfather's brother, again, right, it's a very distant and wrong relationship. He might say that, all right, I know that he exists, but I've never met him, I've never spoken to him. I don't know what kind of relationship I should describe. So therefore, here, degree of kinship meaning close relationship and some distant relationship which exists between the kin members. So, based on this, we have three. I've already showed you in the diagram, primary, secondary, and tertiary. Let us quickly look at the primary kinship. The relationship between mother, father, and their children, which is determined by blood and closeness, is referred to as primary kins. So your primary kins are your family members, right? And in your family members, it will just be your father, your mother, your brother, and your sister if you have one. Normally, I ask my children, when after explaining primary kinship, make your own primary kinship diagram. So what they do is, and most of the time I've seen that they all are single children, all right? And they just make themselves in the picture. They take help of a stick figure. They make their father, their mother. If you have your siblings, well and good. If you do not have, then you just make one single figure of themselves. So the primary kinship, why do we have that closeness? Because we are related by blood. And this often, when we're explaining about family, I've often said that this is almost like a mirror image. Today, if you go back home and then with a very long face, or you slam the door and do not come out of your room for almost half an hour, this will give a panic attack to your parents. Your long face will definitely have a direct effect on your parents. But if you go with a certificate in hand or with a medal in hand or just announce that I've come first in this competition, you should look at their faces, how it lights up. How is it that when you are happy, they are over happy? And when you are sad, they are over sad. How does this happen? Because of this relationship determined by blood and also closeness. That is why primary kins are those kins who are extremely close to you because of the blood relation. These individuals are referred to as primary kins. Sometimes they ask you to give examples of primary kins. So you will have to write father, mother, brother, sister, and wife. Now, father, mother, brother, sister is understood, related by blood. But what about wife? Wife is not related by blood. So here we have two types of primary kins. One is primary consanguineal kins. Look at the diagram. Primary consanguineal kins. Parents, children, sibling. Primary consanguineous kin. Parents, you have siblings and the children. Related by blood. But between these two who are related by marriage, we refer to this as the primary affinal kin. Primary because they are very close to each other, yet not related by blood but by marriage, so they become primary affinal kin. That is why your wife will also come under the primary kin. Second, we move on to the secondary kinship. Secondary meaning the relationship between our primary kins and their primary kin is referred to as secondary kinship, and the relatives are known as secondary kins. Grandfather, aunt, uncle, grandmother. this will become your secondary kin. For this, I would like you to draw your attention towards the next diagram. In this diagram, this becomes family number 1. This is family number 2. And then the last one is family number 3. So we have 3 families here. The reason why I have made this diagram is to explain to you who are the secondary kids. In the first family, let me quickly show you here. We have Anil, who has married Shruti, and they have 3 children, Ram, Maya, and Mohan. In the second family, we have Raj, who has married Riya, and they have a son and daughter, that is Rahul and Shreya. In the third family, from family number 2, Rahul got married to Maya, who is from family number 1. This one is from 2, and this one is from 1. And they had the children Abir and Aina. 2 children, Abir and Aina. Now, let us understand who are the secondary kins. For Abir and Aina, Rahul and Maya are the primary kins. But Rahul also belongs to a family. Maya also belongs to a family. They also had parents. Anil, Shruti, Raj, Riya. These are Rahul and Maya's primary kin. So, for Abir and for Aina, Anil, Shruti, Raj, Riya will be addressed as grandparents. They are the grandparents. Grandparents meaning your parents' parents. So your parents are your primary kin, but your grandparents are your secondary kin. But for your parents, they will be the primary kin. So therefore, secondary kins will be grandfather. You have aunt here. For example, for Abir, Ram will be the uncle. Especially for Aina, etc. Shreya will be the aunt. All right. So grandfather, aunt, uncle, grandmother, they all will come under the secondary kins. Now let's come to the relationship. With our parents, we are very close. I have often discussed, we fight with them also. But with grandparents, because most of the children nowadays, that's what I've seen, do not stay with the grandparents. That's why they see the grandparents only once in a while, or probably they are not very, very they're not very, very close with the grandparents, etc. Aunt also, because of the distance. Sometimes you might have a brother who's living in UK, and probably your children have not seen that uncle of yours, or you have just communicated via the social media, etc. But you might not have a face-to-face interaction. So with our primary kins, we are very close because we do have that face-to-face interaction. But with the secondary kins, sometimes of the distance, or because sometimes they are far away, etc., your relationship might not be that close. So that closeness between one and the closeness which is not there with the other is referred to as the degree of kinship. Now let me just wrap up today's lecture with the last one, and a little confusing one. Here the children get a little bit confused. That is the tertiary kins. Now the relationship between secondary kins of our primary kin and the primary kins of our secondary kin is known as tertiary kin. Now for that it's very, very simple. Let's come back to the diagram. All right. Let's say from here Ram gets married. He gets married, let's say to, okay, we have already written Shreya. Let's say he gets married to Karishma. All right. So for Abir, Ram is a secondary kin because it is Maya's brother. Mother's brother is your secondary kin, your uncle, your maternal uncle, mama as we refer to. But here, since she has come here, now this person has already got married and you have an aunt, so aunt will become your tertiary kin. Secondary kins, primary kin. After getting married, has become a filial kin. So here what happens is that your auntie will be considered as a tertiary kin. Here if Shreya gets married, all right, she gets married to, let's say, Sudhir, all right, she gets married to Sudhir here. Then Sudhir is the uncle, Shreya is the aunt, Sudhir is the uncle. So the uncle will be aunt's husband. That's why I have written here, aunt's husband. Uncle's wife will be considered as the tertiary kin. So with this, I would like to wrap up today's lecture. But before going, let's look at the kind of ISC questions that we're going to get. Define degrees of kinship, the first slide that I showed on degrees of kinship. Examples of different kins. So you might have, give 2 examples of primary kin, or 2 examples of secondary kin, or 2 examples of tertiary kin. For the long answer, this is frequently repeated ISC question. Discuss the degree of kinship along with the examples. For this, I would recommend you, please don't go. What normally children do is they will just define the degrees and give examples. That's not it. Please make use of the diagram. And with the help of the diagram, if you study, with the help of the diagram, if you explain, that will definitely help you to score more marks. So with this, I would like to end. Thank you very much for watching this lecture today. See you next time. Till then, stay safe, stay indoors, and save lives. Thank you.